Alright, so this question is Sudoku solver. So this is a constraint. So the constraint is that you're given a board and then you want to fill out a number for the column and for the row, right? So this is a row, this is a column. Come on. And also this little grid, 3 by 3. So you want to make sure like number you filled in is actually non-duplicated inside, these 3 constraints, right? Come on. So in this question, we're going to use a brute force. Like the idea of this question is to complete the board, not trying to get the fattest, efficiency or anything like. If you want to get the quickest one, the most efficient one, you need to implement a lot of algorithm behind it, because the first thing is that you want to minimize the backtrack, right? So you want to fill the correct number, the high possible correct number into the cell, and then the less backtrack you have, the better efficiency you got. But in this type of question, you only solve 9 by 9. You're not going to solve 25 by 25, right? So this is actually pretty, it's pretty helpful for us to, just using the brute force to write an algorithm to solve to complete the board and put the correct number. So we're going to traverse a row to find out if we want to put the number 1 over here. Is there any collision? No. Okay, then 1 is correct. So we'll put 2 over here, put 4 over here, put 7 over here. So we're going to traverse every single row and column when we put. We don't traverse every single row and column. We traverse the row and column respect the current cell. So imagine you want to put this one over here. So you're going to traverse this one and this one. So this row and this column and also this little grid to find out is there any duplicate value that are just assigned, right? So another one would be this. So I assign 2, right? I'm gonna make sure there's no duplicate. Alright, and then next one 4, and then do the same thing, and then later on I'll put 7 over here. But if you actually notice the column, we have 7 over here, so this is duplicate, right? And also we also check the this little grid. So once we find out there's a duplicate, this 7 doesn't allow, right? We need to backtrack. So we erase this number, we try another number, but we already assigned 1 to 4 over here, right? So 7 was the last number we assigned over here, so we want to backtrack this guy to what? To 7, and this guy to 4, right? And then we know, oh, this is a duplicate again, and then we backtrack this number, and also this number, right? So we find out 4, and then 2, and then 7, and then, oh, this is a duplicate. All right, now we find out. It might be easier to say 2 over here, 7 over here, and then you just keep traversing. So if we're at this cell, we want to know that this little grid is starting from here, right? So we want to make sure the starting row and starting column respect to the current 3 by 3 cell. It has to be correct. Alright, so it's a lot of talking, so let's start coding. And while I'm talking, I will, while I'm explaining coding, and I will explain. Alright, so I'm just passing the function solve the board, right? So I'm going to use a boolean to represent my board. So one way of using a boolean is because I will recursively call this function for the next possible, number, right? So just passing. So I'm traversing the entire grid. Okay, so if a number is empty, right? Empty in the cell, it represents dot, right? So if the current cell does not equal to dot, which means there is a number we assign, so we ignore. Alright, so now we're going to try the possibility from what? K equal to from 1 all the way to k less than equal to 9. and then k plus plus. So this is the number we're going to try, right? And then we want to assign to the board if the value is correct. So if we assign 7 over here, this is not correct because we traverse the column, we traverse the cell, right? So traverse the column, we traverse the row, and then we find out there's a duplicate. So we won't assign 7 over there, right? We're not going to assign 7 over here. So we need to make a helper function. It's going to call if it's valid board. And I need to pass in a board. I need to pass in my current ing, and also the char I'm going to assign. So come here. Is valid char to the array in x, in y, and then char k. All right. So I use another notation to represent ij to xy, right? So okay, so I'm going to just traverse the current row, so it's still going to be the same size, right? So I would say, okay, so if board xi, if this is equal to k, we return false, and in order alright, sorry about this. So think about this. The dynamic value for this, the first if statement is what? Is the column, right? So it's going to be the same row but different column, right? So look at this. So imagine x is actually equal to 0, right? X is 0 over here. I was starting from 0 all the way to the last one, which is 8, right? Because board.length is 9. So we're going to say 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, and then blah, 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 right? So this is for the what? Check the column. Check a column on the same row, right? And this will be the opposite. Why? Because the y doesn't change. So you're going to check this column, right? Imagine you check this column, but your row is going to change, right? Your I is changing, your I is dynamic. All right. So now we need to check the little grid, right? So little grid, we need to have a value initialize star row equal to what? X. It's going to be x divided by 3 and then multiplied by 3 again, and then it will be same thing for start column equal to y divided by 3 and then times 3. So you basically reinitialize the starting position based on your x and y. And so I'm going to using the x represent starting row, I less than the starting row plus 3, right? You only have 3 by 3, and then you'll be paired if I just do like this, and then j equal to not 0, sorry, this guy, and then j less than starting column plus 3, j plus plus. All right, so it's still going to be the same idea. If you find out this is not I mean, this is, if the current cell is equal to the charge k, we need to return false. So you will actually return true at the end. So this is pretty much the idea for is valid. All right, back to here. So we assign the value over here, right? But we are not going to make sure does my the next iteration for the next cell is going to be assigned a perfect number, right? So we will have a backtrack. So we will have a backtrack. Ij equal to dot. You're back to the dot, but before you back to the dot, you need to assign a value to make sure everything is correct. So you assign a value, right? And then you want to keep traversing the rest of the board. So if solve board, at the end you will return true. If this is return false, which means you validate any possible constraint, and then you'll definitely put the number back to the dot, right? So you assign a k and then you put the number back to the dot, right? So this is how you return false. And also once you traverse this for loop, and then you get out here, and then you will actually return false again because you're not doing things correctly. And over here, you will return true because you finish all of every single cell. So imagine you traverse to the last cell, right? The last cell over here, and then this one you don't, 7 and 9 you don't, assign a value, right? So you're not going to access here. You continue, and then you break out the for loop, and then you want to return true at the end because this is how it is, right? So this is pretty much the solution. The explaining might be, not the best, but I would say the coding is the best. Whatever, man. Alright, so what's the time and space? Just think about the board. I'm gonna just draw a paper. So imagine all of the cells are empty. So what's the possibility you can assign in this cell? It's 9, right? Because you can assign 1, you can assign 2, assign 3, right? And so on, right? And what about this? If this value is assigned, it's going to be assigned 8 possible, right? So if this is, I assign 1 over here. So what are the value you can assign? 2, 3, 4, 5, 6, 7, 8, right? And 9. Right? So there are 8 possibility, and this will be 7, 6, 5, 4, 3, 2, 1, right? So this is like a possibility mathematical proofment. So it's going to be 9 factorial for this row, and how about this 9 factorial again, right? So you multiply 9 factorial. So how many? You're going to multiply 9 times, right? So it's going to be 9 factorial to the 9. All right, so this is one type of time efficiency. So if we consider the backtrack, so I mean if we consider backtrack, this will definitely have 9, right? This will definitely have 9, 9, 9, 9, 9, 9, 9, 9 possibility, because in each cell, if you backtrack, you need to try another number, right? You're not going to say, oh, this value I assigned 1 is definitely correct, because what happens if there's number, this is not a fit number over here, right? It's not fit number over here, it's not fit number over here, not fit a number over here. You want to reassign this value to something else, and then you assign 1 over here, right? Just something like this. So it's going to be 81. For each cell is 9 possibility, and how many cells you have? 81, right? So this is another time complexity. So yeah, you can look at this time complexity. So yeah, so it would actually based on your solution, and then space is constant, right? Space is constant. You not allocate any space. So this will be the solution, and yeah, it's supposed to be easy, but just based on the algorithm, if you want to solve really efficiency, you need to better. I mean, you need to get better algorithm for this. But in this question, you don't write a efficient one. You want to write a good one to complete your board. So this will be a solution. And if you have a question, leave a comment. See you next time. Bye.